Hello everyone, I'm Gay Chego. My report is all about logistic regression in Python, handwriting recognition. Let's start. Handwritten digit recognition is an interesting machine learning problem in which we have to identify the handwritten digits through various classification algorithms. There are a number of ways and algorithms to recognize handwritten digits, including deep learning, CNN, SVM, the Gaussian Bayes, and others. So, in this article, we will deploy a variety of machine learning algorithms from the sklearn library on our dataset to classify the digits into their categories. So now, let us first look at the dataset. We will use sklearn's low digits dataset, which is a collection of 8 times 8 images in 64 pictures of digits. The dataset contains a total of 1,797 sample points. Now, let us import the dataset as digits. So, here are the example from sklearn dataset. Import load digit equals load digits. So, and this is another example. Key, type, size, and value. So, in the key type, we have the discrete data, feature name, frame, images, target, and target name. So, in the type column, we have the string, float, list, non-type, float, and integers. So, in the size column, we have the numbers, and the value, we have the digits dataset. So, the discrete provides as description of the dataset. The dataset contains images of handwritten digits. 10 classes where each class refers to a digit of 0 to 9. So, as you can see here, we have 0 to 9 in this example. So, in Python, we have an code here. And step 1, import packages in Python. So, next, we have another example let us visualize the first image of the handwritten digits stored in images and plot it using matplot library. So, this is my example. Import matplot library.pilot as plt, plt.gray, plt.matShowDigit.image0, plt.show. So, as you can see here, the output will be as follow. It shows a handwritten 0. So, next, we have an example here. So, we have 2 pictures, and it can be verified by opening up the images numpy arrays in the variable explorer and resizing it so it can be easier to visualize. So, next, we have another features or example. Our dataset also consists of a numpy arrays target. which store the label of the images. The target name NumPy arrays stores the label values, the actual number, which is the same in the case. So there are three pictures here. The first picture, we have a number 5. So if our images 35 store the following 8 times 8 images, which is the number 5. So in the first picture, we have number 5, and the second picture, which is the target arrays, will store its level in the 35th index place target 35. So as you can see, the second picture, we have the target arrays will store in 35. And the third pictures have the target names arrays will be the same of the labels classes, which in the case of digit recognition are the digit themselves. So next, step 2, split data. It is good and widely adopted practice to split dataset you're working with into two subsets. These are the training set, the test set. This split is usually performed randomly. You should use the training set to fit your model. Once the model is fitted, you evaluate its performance with the test set. It's important not to use the test set in the process of fitting the model. This approach enables an unbiased evaluation of the model. So this is the example of train test, split, and performance matrix. Once our dataset is loaded, we will start the coding by importing the train test, split, and performance matrix. So this is the example. And in preparing data, next, we will prepare the data for training by declaring a NumPy arrays data and reshaping it so that it has the first dimension equal to the length of the images, which is the number of samples n samples, but with reduced dimensionality, so the dimension of data will be 1797 times 64. So this is the example in preparing data. And splitting data into train test, splitting data into train and test. The next step is to use the train test split function to split our data into 50% training and 50% testing data. So this is the next step in splitting data into train and test. So we have the name, type, size, and value. And the name column, we have the X test, X train, data, digits, and samples, Y test, Y train. And the type column, we have float, utils, and integers. And the size, we have the numbers, and value, we have the minimum and the maximum. So in splitting data, we have an example here. So Python X train, X test, Y train, Y test, train test, split, Y X test, size is equal to 0.2, random state is 0. So, we have the function returns a list with 4 arrays. So, first, X train, part of X used to fit the model. And the second, X test, part of X used to evaluate the model. And Y train, part of Y that correspond to the X train. And Y test, part of Y that correspond to the X test. And step 2, scale data. So, standardization is the process of transforming data in a way such the mean of each column become equals the 0. And the standard deviation of each column is 1. This way, you obtain the same scale for all columns. Take the following step to standardize your data. So, here are the 3 steps to standardize your data to calculate. So, first, calculate the mean and standard deviation for each column. And the second is subtract the corresponding mean from each element. And the third, divide the obtained difference by the corresponding standard deviation. And the Python, we have a scalar standard scalar and train scalar with fit that transform X train. Fit transform fit the instance of standard scalar to arrays pass as the arguments transform these arrays and return the new standardized arrays. Now, X train is a standardized input array. So we have an example here in Python. In step 3, create a model and train it. And step 4, we have evaluate the model. So as you can see here, we have some example of the code. And next, we need to classify, or we have to classify them. So, once we're done with the above step, we will use different algorithm as classifier. Make fractions, print the classification report, the confusion matrix, and the accuracy score. The classification report will give us the precision, recall F1, score, support, and accuracy, whereas the confusion matrix will show us the number of true positive, false positive, and false negative for each classifier. So, in this report, we will use the following classifier from Sklearn, and the first one is support vector machine. So, in support vector machine or SVM, here is the code to define the SVM classifier and use it to make predictions. So here are the SVM code, and then the classification report for SVM classifier. The SVM classifier gives an accuracy of 0.9688. So, here are the classification report. It generates. So, in the next is the example of confusion matrix for SVM classifier. So we have the predicted level and the true level. So, and then the second is the Gaussian naive Bayes. So the Gaussian naive Bayes. Next, we will define the Gaussian naive Bayes as the classifier GNB classifier. So, here is the code to define the GNB classifier. The accuracy of the Gaussian naive Bayes classifier was found out to be 0.8075. So the Gaussian naive Bayes classifier is less accurate than the SBM classifier 0.9688 when it comes to recognizing handwritten digits. So the comparison of support vector machine is and the Gaussian naive Bayes is less accurate than the support vector machines. And here are the classification report for the naive Bayes classifier and the confusion matrix as follows. So here are the example in confusion matrix for Gaussian naive Bayes classifier. We have the projected level, true level, and confusion matrix. So that's all. Thank you.